and welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
So, continuation of the friction discussion. Static friction is characterized when acceleration is equal to 0, body is standing still. And friction is less than mu n. Those two conditions both have to be applied and both have to be valid. Kinetic friction is that we push stronger, acceleration appears, friction can grow only to mu n, friction is mu n, acceleration is positive. So either one of two is standing or moving, but each case means two conditions. Two conditions, and of course this is generic form of second law of Newton law, and this is static, this is kinetic, this is exactly like this, so I can remove it. And I probably can remove this because I don't want to repeat myself again and again and again, and if you don't understand this you have to visit. And we noticed last time that the graph of friction was like that. And I probably can remove this too, because this is a question about the pile of, I don't know, sand. So if we put a pile of sand, it would be like this. If we go and we see dunes, they cannot be very steep, because if they are steep, this thing has to slide, and this becomes less steep. So we can pile and pile and pile sand, but only to the bottom. Take your hourglass, take your sand, or you can go with the snow. As you probably noticed, I love to ski, hence those my ancient ski here have a second life, because now I ski completely different set of skis. I don't want to go there, because although it's pure mechanics skiing, and I can tell you a lot about skiing, well, maybe I will one day, but not today. Everything is based on mechanics and on my understanding of second law of motion, the way I ski, believe it or not. But anyway, if we have mountains, and then there is a run, and this run is very steep, it's become very dangerous because avalanche can slide. And so the question is, we know what angles are dangerous. We know that if we're standing on a relatively flat run, nothing happens. And we also know that steep run also safe. And why is that? Because on the steep run, if the run is this, the snow doesn't accumulate, it released. So this is a very dangerous range between this and this. When the snow accumulates, the skier comes, triggers the avalanche, and then something terrible may happen. Not fun. So, what is the explanation? Why am I talking about this? Because actually, let's talk about sand, snow, doesn't matter. If we have particle, and this particle is this body, and this is the maximum slope, maximum incline, it stays without sliding. What should happen? We have exactly this picture applicable to this piece of sand or piece of snow, same vectors, only it's applicable not to the imaginary body brick on the incline, but to the real particle of sand or particle of snow. And everything that I said is applicable. And the most dangerous situation when it's about to slide. You need a little push. Like remember I was drawing this diagram. A little push above, and we have, instead of static friction, when everything is in stable condition, we have kinetic friction when a mountain is sliding down the slope. And it's not the place to be there. So basically at that moment we have kind of both worlds. We have this and this. So on one hand, so this is how physics works. On one hand we say that acceleration equals 0, and that means that mg sine alpha minus F friction equals 0. But on another hand, we say that F friction is maximum, and it is mu n and mu mg cosine alpha. So we kinda on this graph, and we kinda on this graph, and it happens only under certain angle alpha 0, and we have this, and we can plug a friction here, and we can say mg sine alpha. I'm not plugging, I just simply separate this to other side and move this to the right, changing sign. Or if you're still not comfortable with this, I can say let's add plus F friction to both sides of equation. This will cancel out, and on this side it would be F friction. So mg sine F friction, and friction comes from here. It would be mg sine alpha, and F friction would be mu mg cosine alpha. And there is a lot of things that be cancelled out. We can divide both sides on mg. Divide both sides on mg, so we put mg here, we put mg here. Equation would be the same, this would be cancelled out, or I can do it like a little bit faster as I did it right away. Cancel out the factors right away. I have sine alpha equal mu cosine alpha. And since I'm looking for mu here, I don't need this. I have sine alpha divided over cosine alpha equals mu. And how I got it? I divided both sides of equation on cosine alpha. Dividing into cosine alpha, this will be gone here, and this will not be gone here. So sinus sine alpha over cosine alpha equals mu, and I write it as mu first, and sine over cosine is tangent. And this is basically the great way to find the friction of sand over sand. You just look on this pile of sand, or incline that sand dune has. You have to, of course, look for that there is no wind, that it is steady day. But basically, you get an idea. You look, and if, for example, sand over sand, or snow over snow, you look and you get it. So for example, snow over snow is alpha equals 30 degrees. I know that tangent 30 degrees equals square root of 3 over 3 equal 1.7 divided into 3. It would be around 0.55. So I know immediately that friction snow over snow is around 0.5. Right away, very simple, and it's pretty much true, and it would be pretty much similar with the sand, because sand will be 40 degrees probably, it will hold itself, so tangent would be bigger. You can find with your calculator what it is. And I hope that slowly but surely you're becoming more and more comfortable with this idea of friction. And you understand that it's two types of friction, and one type is characterized by this, another by this, and then there is a boundary. Then both are kind of valid, and we use this condition, and we use this condition. So from this condition we use equation, and from this condition we use equation, because it's easier to deal with equations than with inequalities. All right. And now, because you are so proficient, I will give you a little bit more complicated problem on friction. I promise I already know what I will give you next. Do not miss this moment. Subscribe bell, like if you like, and have a question, don't be shy to ask it. There is no stupid questions, there's only stupid answers. Trust me on that. If somebody tells you that your question is stupid, this person is stupid himself. The questions can be only smart. The answers can be stupid. That's true. See you next time.